this is the first in a series of technical seminars, which are going to be brought to us from Swallow's Independent Jaguar Specialists down in the Southwest. So we have Tom Robinson from Swallows. We also have Dan from Swallows and Colin Porter on the call as well. And we are going to concentrate tonight. Tom is going to give us an overview of what Swallows do in terms of their performance upgrades. But we are going to predominantly concentrate on superchargers and air filters, with a view to then moving on to suspension and braking upgrades in a later seminar. But there will be a whole host of things covered tonight as well. And what I would ask is, Tom's going to do a presentation to us. And then after that, he's going to come, part of that presentation, he's going to cover off a few of the usual questions that he gets asked. But after that, you're able to ask questions yourselves. And what I would say is, if you could use the chat function, so at the bottom of the screen, you will see a little tab that says chat. And in there, if you click on that, you're able to type questions. So any questions that come up, if you can use the chat function to do this, that would be great. I'll be keeping an eye on these questions coming through. And then I'll be asking Tom those questions, or asking you to ask those questions to Tom if it's too complicated for me, because to be honest, they probably would be, after Tom's presentation. So a big welcome to everybody. Tom, I will hand over to you to start the presentation, and you're going to share your screen with us, Tom, aren't you, my friend?
Yeah, absolutely. I'll just do that now. Can everyone now see that?
There we go. Technology is working, so we're off to a good start, Tom.
Yeah. Right. So is that all good? Everyone can see that?
There we go. I'm even going to put myself on mute, Tom. How's that? Okay.
So thanks for the intro, Andy. First of all, it's great to see so many of you on the call. I'm pleased that there's so much interested in some of the modification on the Jaguar. So as Andy said, this is going to be a bit of a series. So we're going to start quite light, basically. So firstly, I thought I'd introduce who we are and what we do. So obviously, as Andy said, we're Swallow's Independent Jaguar Specialists. That's predominantly what we are known for. So my dad established the business back in 1985. I am a third generation of Jaguar Specialists, which is a bit of an unusual thing to say, but it is me, my brother, my dad, and my granddad was involved at some point, who is now retired. So we've been specialising in Jaguars for 35 years. We were originally based in Ruislip in Middlesex. Over 20 years ago, my dad bought the farm at the location we are now, which is where we're permanently based. We don't run two separate branches. So, sorry, someone else is on picking up there.
What's up here?
I'll mute them, Tom. It's okay.
No worries. So after my apprenticeship, I took over the company back in 2015. And that's when, with my experience, we focused on the more modern Jaguar range. So ultimately, our day-to-day vehicles that we look after are from sort of 2000 onwards. So that is where my experience is, and that's what we focus on. And that is also when we as a company launched the Swallows Racing side of the business, which some of you may have seen, which is the SR logo. Now, Swallows Racing, so that's the Swallows Racing logo. Ultimately, racing to us was a hobby. So it started officially back in 2015. Now, the ethos of that was to basically provide race-proven or performance track-orientated parts for road Jaguars. So we wanted to take products that we used and develop on track for road use, which is something that not a lot of companies actually do in testing them on track. That was really key to us. So I spent most of my childhood, it was quite normal for me to be on the side of a circuit. We were always leaving on a Thursday and we wouldn't be back till Sunday night late. My dad competed in karts, so 250cc national supercar to quite a high level. He ran in the British Championship for quite a long period of time and has got quite a few titles, but I don't always give him much credit for that, obviously. So as I said, ultimately racing was a hobby with us and it's always something that we've done, but officially back in 2014, I decided to build an XJR6 manual to compete in the Jaguar Enthusiasts GT Championship. Now, I quickly found out that it actually was probably not the most competitive car of choice. The XJS, being a GT, seems to be the most developed car in that series, and I found that there was quite a few teething issues using the saloon being quite a heavy lethargic car, and a supercharge application was actually quite awkward in the racing series that we were running with. So Swallows Racing is now a large part of the business, and it's a huge passion of mine and quite a lot of the other staff members, and also my dad as well. So we offer a large range of products, and we've been
Tom, can you just unmute yourself, mate?
Is that back now?
Yeah, that's it. Yeah, you're back.
Yeah, so we've been lucky enough to secure some partnerships with some of the world's leading brands. So we're really lucky. We've got some close relationships with companies like Tarox Brakes, Pipercross, who develop air filters, Bilstein with dampers, iBack with springs, and new Maguires. Some of you have probably seen the Maguires build that we've been involved in. That was a great thing for a company like us to do, and that gave us some of these connections with some of these brands. So we also have our own in-house design and engineering fabrication facilities, so we're always adding to the range and developing new products. Hence why we're still racing the XJR6 application, which I'll get onto later. So as Andy said, this is something that's quite new to us, the seminars. So we are going to go into detail on some of the other topics later, but ultimately we're going to talk about modifying your Jaguar. So we get asked quite a lot of questions on various topics. So I thought I would go through some of the questions that we get asked regularly. So we're going to get rid of some of the common myths, misconceptions of tuning. We're going to talk later on about some of the supercharger pulley upgrades that we offer and various other companies also do offer, and explain the differences between them. I'm also going to go a little bit into some of the different supercharge applications that are fitted on the Jaguar range and how they've changed through the years. I'm not going to go into massive detail, just more applications that's used across all the model ranges rather than just one model specific. And then we'll talk about some other products that are related to modifying your Jaguar that sometimes come hand in hand with tuning. So I've also got Dan, who's one of our colleagues who works with us here. He's on a call, so he might jump in on some of these questions. So these are the kind of day-to-day questions that we get asked all the time based around tuning and mapping. So firstly is, what is tuning and mapping? So ultimately, most modern vehicles have an ECU which controls, is a management system, controls the running of the car. So chip tuning is a term that's commonly known with the more earlier ECUs, where we physically have to remove hardware and program a chip to that ECU. So that's where the chip tuning has come from, and that's now evolved into a more modern ECU platform where we as a company can physically take a read from that ECU. We can look at the data that's on that ECU and we can modify it accordingly. So there's various ways of doing that, and there's various tools that can do that. I won't go into all the details on that, but ultimately certain models and ECUs we can do via the OBD port. So that is where we will do any diagnostics for a car with general maintenance. So we can take a read via it that way, and then we can modify the tune or the map that's on that ECU accordingly to that vehicle. Now, sometimes manufacturers decide to make it a little bit more awkward for companies like us to modify these cars, and sometimes we physically have to remove the ECU for the car and program that on the bench. So we'll do it exactly the same as we would do with an OBD. We're just trying to read the information that's on that ECU so we can modify it. So that's a little bit of basic, but ultimately we are just modifying that software that is already there. We're not adding any hardware or completely changing it. We're just modifying the parameters that are already there. So next one is something that is just asked day in, day out. So why hasn't the manufacturer given us this extra power standard? So there's a multiple array of reasons for that. So you can go into a lot of different aspects, but sometimes manufacturers, when they launch a model, like for example, the Jaguar 5-litre supercharged engine, that's used in various different applications. That's used for a long period of time. So Jaguar offer various different power outputs on that. So that is why they will sell a reduced power version to start with, because they want to use that engine for a considerable period of time and be able to offer you as a customer different options and to be able to add those from the factory. So sometimes the factory options is just a different modification in the tune to allow that power. So that is why, one of the reasons why manufacturers do that. And also, a manufacturer ultimately is supplying a car to a huge amount of different users. So it will go to different countries, different temperatures, and they want one setup really that will work across the range. They don't want to be having a different map for a different country and all of a array of different softwares to allow that. Sometimes different markets do have slightly emissions related setups, which will be included, but ultimately it is very similar. Now, will my engine's life expectancy be shortened? Technically, no, it will not if it is done correctly. So manufacturers, again, leave a huge margin of safety when they're designing engines. I mean, they're designing cars to last long periods of time. So no is the answer if it is done correctly. Now, fuel consumption, this is another one that people often ask us. If you are tuning a car, believe it or not, you can actually see fuel economy gains with tuning a vehicle, which is often quite surprising. Obviously, in race applications, we aren't looking to look for fuel consumption ultimately. We just want as much power as we can possibly keep stable for as long as possible. So on a road car, is what will happen, especially with the automatic gearboxes, is as you improve the tune of the car, you'll also increase torque. And ultimately, if you're increasing the torque, you can pull a higher gear at lower RPM. So that is why you'll often save fuel with a tune. Now, will it affect my insurance? Yes, it will. Ultimately, you should always let your insurance know if your car has been modified. Different insurance companies take different views on this. I'm sure some of you may have already experienced this, but ultimately, as long as you do let them know, sometimes it has no effect on your premium, sometimes it does. And lastly, we always get asked how long it takes. So actually tuning your car isn't a long process. There's various different aspects for that. But if it is just, for example, I don't know, 3-litre diesel XF, something like that, that's an ECU that we have to do on the bench. That really takes around 2 to 3 hours for us to tune that. If it's done via the OBD, that does reduce the time. But developing the ECUs and all of these different tunes for these vehicles is a massive amount of time and commitment into doing that. Obviously, we want to offer a product that we can guarantee that isn't going to cause you any issues, and we want to give you a vehicle that's going to give you the best drivability across all that ranges. So the development process takes a hell of a long time and a huge amount of man hours to do that. So on to the next slide. So common myths, misconceptions of tuning. So first on the list is BHP figures, power figures. That's what ultimately everyone's looking at with regards to tuning. And this is something that we see day in, day out, and we get asked all of the time. So why has my car got less power than the manufacturer states when we've put the car on a dyno? So ultimately, manufacturer measures the horsepower at the flywheel. So they will do this on an engine dyno. So most of the time, the engine will be actually on the bench and it will be dynoed that way. That is how they get that figure. So when we offer a dyno or a power run on a vehicle, we will do that on what's called a chassis dyno. So that is when the engine's in the car and the car's in a driving state. So most of you have probably seen a dyno setup. There's 2-wheel dynos, 4-wheel dynos, all different types. So when we're measuring horsepower in that aspect, we are measuring from the wheels. So if you can imagine, you've obviously got the engine at the front of the car. Obviously on a Jaguar, you've mainly got an automatic gearbox. Then you've got a prop shaft, you've got a differential, and you've got tires as well. So all of these factors have a huge effect on the power output of what that dyno is reading. So for example, if we're measuring at the wheels, whereas the manufacturer is measuring at the flywheel. Now, most modern dynos will calculate back to flywheel, but they're using a multiple amount of calculations to do that. And they are generalized figures. So for example, tire pressure makes a massive difference on a dyno to your power figure. The losses through the transmission and differential. A really good example of this is actually, I think I've just seen Dale on, is Dale's Maguire's build. So We kept that. That was an automatic car when we first got that. We dynoed it with the automatic box. Once we'd finished the conversion with the manual, so we got rid of the automatic gearbox and put it on the same dyno under the same conditions, and we gained nearly 50 horsepower wheel power without doing any other modifications. So that'll give you an idea of some of the horsepower that's potentially lost through the transmission and other components on the car. Now, I'm just going to show you a dyno graph. So this is a typical dyno graph, and Dan might also want to point out a couple of pointers on this. Now, this is one of the things that can cause issues with differences in dyno reads. So ultimately, this is at the flywheel. So we're measured at the wheels, and it's the Dyno Dynamics dyno is calculating it back to the flywheel. So when we first dyno run the car, we see this at 380 horsepower. Now, as dyno reads go, that is actually quite close to standard figures. Looking at this, this is an F-type, so it's a V6 F-type supercharged 3 litre. So that started off at the 380 horse. After we'd finished tuning it, we ended up at about the 433. So these figures as a whole to us aren't necessarily, to the end user, they want to see obviously the biggest number possible, but to us, we are looking at the difference from the stock figure that we've run it at, which is our base figure, to the maximum power output there. So we're interested in that difference. The actual figures to us don't mean a huge deal because of all those potential differences. This one probably isn't the best example because it's actually really close to stock power, but I guess is what I'm trying to say is please don't be concerned if on a dyno run you get varying results and it isn't stock power. There's very rarely anything wrong with a car. Before we tune a car, we'll always data log it and make sure there's no problems with the car before we do that anyway. So the red here is your power curve basically, and then you've got the torque running across these. So green was before, red's after. So as you can see with the tune that we've done on this car, we've added a huge amount of mid-range torque. So coming in at, well, I mean, the power's actually up all the way from sort of 2,500 RPM all the way up to the rev limiter. So, I mean, looking at that, it's about 100 foot-pound increase there, which that is massively noticed from a driver perspective. If we're only adding power to kind of the last 2,000 RPM of a car, it's not going to be noticeable for road use. Racing, yes, you're going to be in that rev range a lot, but for road use. So when we're developing a lot of these tunes, this is all stuff we're equating for. We want to make it as drivable as possible, and we want to make it as smooth as possible. There's no point having no power here and suddenly having a massive spike midway through the graph, which is what we're trying to avoid. Now, a couple of other things that I just want to point out on regards to dyno graphs, and it's something to always look out for. Often a tuning is known as a bit of a black art, but ultimately it is fairly simple. And often certain parts of the industry, things are covered up to stop people or the end user understanding what's going on. So dynos, as I said earlier, are based off calculations. So there's a huge amount of data that it's reading. So if any of that data is incorrect, it potentially can give you a misread. So on a Dyno Dynamics dyno, when you are doing a power run, you put it in what's called a shootout mode. So when it is in a shootout mode, all of those parameters are locked. You as a dyno user or a tuner cannot change anything. So when it starts at your low RPM, you'll rev it all the way up. You cannot amend anything on that dyno. It is in that shootout mode. So this is the shootout mode chart here. So all of these data points are part of that. So for example, you've got barometric pressure. I'm not going to go through all of them because we can talk all day about this, but a couple of, just to give you a couple of examples, you've got intake temperature here. So that's the temperature of the air that's going into the car at a time. Now, for example, that's one of the calculations that dyno uses to calculate back to flywheel. So for example, if that intake temperature there was higher than it should be, so that's 37 greens stating here. So that's about right. So I don't know when this dyno was done, but obviously that's normal temperature. You're in a dyno cell, so temperatures in there can be warmer than normal. You've got very little airflow until the fans are on. So that is quite average to see that. If you're seeing a figure of sort of 70, 80 degrees, something higher than it should be, than's physically possible, all this pressure here is higher than, I don't know, say 1,000. This one's just over 900, so that's about right. that means ultimately that potentially there is a skew somewhere on the figure. So if we increase that intake temperature by 50 degrees, that could give us a 20 horsepower increase on the bottom line, because it's using that temperature as a calculation to calculate back your flywheel. So that's just a little point, that we will always never really take a dyno printout word for word until we can see that all of these data points here are somewhere where they need to be. Okay. So now tuning boxes. We don't recommend tuning boxes personally here. There's a huge wealth of different types of tuning boxes that can be bought. But ultimately, when we tune a car here, we are modifying the original ECU that is fitted to the car. So we're not adding any hardware to it. As I said, it is software related. Now, tuning boxes, I'm going to talk about mainly tuning for diesels with the tuning box. So there's various companies that there's all different brands. I'm not going to really talk about anyone in particular, but tuning boxes do vary on what they do. Now, the reason they vary hugely is because of what they are doing to the car. So we are modifying the data that's already there, whereas a tuning box is technically interacting with the data that's there. So a lot of the diesel tuning boxes connect to, for example, on a diesel, to your fuel rail pressure sensor. And is what they will do is they will ultimately trick the car into misreading that pressure sensor to increase the amount of pressure from that diesel pump. So say, for example, your fuel rail pressure at a certain RPM should be 2 bar. It will say that the actual pressure is only 1.5 bar. So the ECU goes, hang on a minute, I'm seeing less pressure than I should, and it will increase that, which will in end give you performance. But is what that won't do is, like we talked about earlier, won't give you that smooth drivability. With diesels, that could cause excessive smoke, whereas when we're developing a tune, we take all of those factors into consideration and try and make it as best as possible for that end user. Out and out power isn't necessarily the best, and you can cause other issues in doing that. Now, if you can imagine, if we're going over to a supercharge application, and we've got a whole host of other things going on, and we're plugging something in that is technically interfering with the data on those sensors, for a safety parameter, if it's causing something that is to go to a miss, it could cause the car to potentially run lean, it could cause the car to overfuel, you might generate misfires. So that's why we personally as a company don't do anything with tuning boxes. We prefer to modify the hardware that's already there. And although that can cost more to the end user and also to us as a company, we have to spend a lot of time developing it. Now, the next one here is stage maps. In the tuning industry, most things are talked about in stages. Now, this is just something that we like to clear up, because we also offer things in stages, and that's mainly because that's how the industry offer it, and that's how most people understand it. So stage 1, 2, and 3 maps. Now, to be brutally honest, there is no real difference. If we are talking about a package where, for example, on a supercharged car, we are adding a supercharger pulley, so we're increasing boost, we would call that a different stage. So we would modify the tune differently for that to allow that. But as a standard car, we as a company do not offer any different stages of tune. The tune we offer will be the same across the board, unless we are adding hardware. So as I was just saying, if we add a supercharger pulley, we'll modify the car differently and offer a different tune for that. And same goes with eco maps. Now, that is something that companies like us can offer, and we can develop a tune or target a tune for more of an eco than an out-and-out performance. So, for example, one of the tricks is some of the ECUs are based off torque limiting. So what we can do is we can increase torque at a certain point to trick the car into changing it to a gear at a higher RPM to pull, because you have higher torque, it will pull a higher gear at lower RPM, which is where you'll get your potential miles per gallon saving. So that's what an eco tune is all about. Sometimes you do see the same out and out power, but you might have the power delivery at a different point in that rev range. Hopefully that all makes sense. Anyway, so difference in tuning types. Now, that is something that I touched on earlier about whether we have to tune the vehicle via the OBD port or whether we'll do the ECU on the bench. And that's often the biggest difference in prices between the difference on tunes. It's a lot more labor intensive, as you can imagine, to remove an ECU from a car. Different manufacturers and different models put those in different locations. Sometimes you can have kind of an hour to 2 hours labor just to remove the ECU. A really common one for us is the 3-litre diesel, something we tune day in, day out. They're really responsive to a tune, but we have to still do those on the bench. Now, when I say we do it on the bench, if you can imagine, we have the ECU out of the car. Different firmwares and different types of ECU generations will have different ways of actually us being able to tune them. So we're actually essentially hacking this ECU. So we want to see all the tables and all the data in there. And obviously the manufacturers don't want companies like us to do that. They want you to go to them and they want to offer it as a factory option rather than someone else being able to do it. So certain ECUs, we have to physically open the casing, and they're often silicon shut. So you can actually damage the ECU. So it's something you've got to be really careful of. And sometimes we even actually have to solder to the board itself on the ECU to be able to read the data. We might have to read the data like that, and we might then have to completely change how we upload the ECU software. So for example, certain ECUs will have to change the location to read as we would to upload that tune. So it's something that we're constantly moving forward. And there's a whole host of companies out there that are developing different solutions for these ECUs. So going back to the 3-litre diesel XF, we now have a solution for these where we still have to remove the ECU. We can't do it via the OBD, but we have a direct connection. I mean, Dan, you do these all the time, don't you? You know yourself, it speeds the process up massively, which we can then pass on to the end user. So instead of risking open ECU, we can connect to the boot pins, which is the pin that your wiring harness for the engine plugs into, and we can upload and read the data that way. And that is ultimately the biggest cost differentials between the tuning on various models. If it's a newer car, obviously we take into fact a little bit of the risk factor. If it's a car that's under warranty, some of these ECUs can be up to £2,000 or £3,000 down on certain models. There's a huge amount of cost. So if we open that ECU and damage it, obviously we're going to have to look at covering the cost of that. It's not something we'd pass on to the end user. And that goes on to really talking about kind of cheap remaps. So it's a massive industry, and there's a whole host of companies out there that can do what we do. But the difference is in price is the amount of development that goes on behind the scenes. So an example I often give to people is, if you go back to kind of going off the Jag topic, something like your Sierra Cosworth, something like that, the very first EFI engine management systems, which is like 15 years old, you'll have around 20 tables in that ECU that are actually of any interest to us to calibrate. And you'll have about 50 different switch points that you're looking at. Now, to give you an example, a 3-litre diesel XF could have up to 5,000 different tables in different locations. So if you can imagine someone that's at home tuning these vehicles, they're either copying these from someone, or they aren't able to necessarily access all the data that some of the bigger brands, and there's a huge industry that are cracking these ECUs and working out all of what these tables can do. I won't go into any detail on any specific ECU. I'm sure Dan will say the same, but some of the later Bosch management systems, most of the Bosch management on the Jaguar range, we can gain a huge amount of performance over the earlier Denso manufactured ECUs. For example, most of you know the difference with the SVR F-Type. We can gain kind of 50 horsepower just tuning that car, which is just huge. And all of that is ultimately the difference between the 510 option to the SVR. It's just in the management systems you've got. A lot of the ECUs work off torque control, so they'll limit the amount of torque, and we can edit all of those tables. So hopefully that's covered most of the common misconception. Is there anything else, Dan, you think that I've missed there?
No, I think probably one of the questions that's going to come up is, why is there, if it's the same ECU or same engine but different ECU? Essentially, it comes down to where the people have been spending the time developing. The tables are a lot more commonly able to be found, whereas people like in the Denso ECU,
Yeah.
They're a lot more difficult to find, and they're hidden under different aspects where you'll be looking at one and it will look like a torque limiting table, when in fact it'll actually be air intake temperature at 70 degrees, where it'll be something ECU never sees.
Yeah, that's actually a brilliant point. I'm glad you picked up on that, because just going through, like I said, I don't want to delve too much into model specific, but if we just talk about ECU brands, so the earlier 4-litre supercharge application uses a Denso ECU. Now, as Dan said, essentially the industry is led by the amount of demand it has. So your VW, your Audi markets, that the German market, the tuning industry is huge. Jaguar is obviously very small in the scale of things. So, for example, the later Bosch ECUs that fit to the Jags, that is very similar firmwares to some of the VAG applications. There can be a lot of differences, but there's a huge amount more people that are able to crack those ECUs than the early Denso ECUs. And for us as a company, I mean, you can spend tens of thousands of pounds developing these cracks for these ECUs. It's absolutely massive. And that's something, I think I've seen Andy Stoddart on the call somewhere. I know Andy, for example, is still able to modify the early X300 ECUs and tables for the supercharged cars, whereas a company like us, we don't have the experience in doing that ECU with a standalone management, where we can see all the VE tables, ignition and fuel timing. That's something that we can do no problem on dyno, but the actual OEM application, as Dan said, is essentially scrambled, so that people like us, it's very awkward for us to do that. Right, so superchargers that are fitted to the Jaguar range. So going back to the straight six, that I believe was Jaguar's first production supercharged car. So they used the Eaton M90 supercharger, which is number 1 on the diagram here. And that essentially supplies 90 cubic inches of air per revolution. So every time that supercharger turns, that is what that is putting to the engine. So in terms of superchargers to date, that is actually quite a small supercharger. And with my XJR6 that we race, which I'll touch a bit on later, we've actually gone to a much larger application. We actually use the same supercharger that's fitted to the 5-litre. So the 4-litre V8 generation and the 4.2 generation engine, so come in at around 96, starting with the 4-litre. Then after 2002, 2003, changed to the 4.2. They use the Eaton M112, and same with the name. That is 112 cubic inches of air per revolution. So that is how much that is supplying that engine. Now, with the modern 5-litre generation, they actually are still using an Eaton supercharger, but it is quite vastly different. So it's called the TVS 1900, and that is a new generation of superchargers that Eaton have developed. So essentially, it is far more efficient than the earlier type supercharger. So I believe it's a patented design by Eaton, but it's a 4-lobe rotor design rather than 3 on the earlier superchargers. So to give you a basic overview, essentially at a higher RPM and a higher boost ratio, it is more efficient than the other superchargers. So now you can also run these at higher RPMs as well. So like I said, none of these are model specific, but that is the 3 different generations of superchargers fitted to the Jaguar range. And now I'll go on to some of the pulley options for these different superchargers and explaining as and why we do that. So going back to the XJR6, the XJR6, as I said, has the M90 supercharger. So the best way to add performance to these, ultimately, as I said, tuning wise is a little bit awkward with them, but someone like Andy can help hugely with that. Now, ultimately, we want to add boost to that car. So we want to add more compressed air. So I always like to give the example, essentially a supercharger is a multiplier. It's multiplying the amount of air that's going into that car, in turn giving the vehicle more performance. So with the M90 is what we like to do on those to gain the most amount of performance is we actually, to change the boost ratio on a supercharger, you have to actually physically, mechanically change pulleys. So we call it a drive ratio. So the easiest way to explain that is it's like the bicycle chain effect. If you reduce the upper pulley, it will increase the RPM of that supercharger. So at the same RPM, there'll be more revolutions of that charger, which in turn should give you more boost, more air going into that engine. There's a whole host of other effects which I'll talk about in a minute of doing that, but that's really the basics. So with the XJR6, we recommend the lower crank pulley. We can increase this by around 16%, I believe, and that is the best all-rounder for that. And then essentially then the ECU tune can be modified to equate for that. So going over, this is something that we get asked all the time. When it gets to the V8s is where there's quite a lot of other options on pulleys. So the straight six is fairly simple on that. There's various different pulleys out there. Most are similar dimension. The one we've tested is 16% increase on drive ratio. That offers us the best all-round balance of performance. So that's what we recommend. Now, 4-litre V8. So that's the 308 XK8 generation engines, and that's with the Eaton M112 charger. So that is a lot bigger supercharger, and it sits in the middle of the V there. So there's quite a few options available for supercharger pulleys on this application. The quoted power on these is 370 as stock. Now, certain companies, and including us, we offer a lower crank pulley for these, so we can increase the drive ratio that way. And also you can add an upper supercharger pulley to the 4-litre supercharger. So there is two types of different upper supercharger pulleys. We personally only recommend the 6% pulley because the reason for that is, one, no material has to be removed from the supercharger to fit it. It fits on the existing casting, so we can pull the old pulley off, we heat a new one up and we can fit it on, and there's no other modifications needed. Now, there's quite a few different types in the market, but quite a few companies also offer a 10% pulley. So 10% pulley on the supercharger, unfortunately, does need some machining work. So some people can do this in place. It's not ideal. Realistically, the charger needs to come off to do this effectively, but you need to machine about 2 or 3 mil off the nose cone off the supercharger so you can fit it. Now, is what we have found as a company testing these and racing these is when you're running the pulley ratios too high. So we're running these superchargers essentially at their maximum RPM. All of these superchargers have an efficiency range. So when they come out of that efficiency range, essentially the more air you're compressing, the more heat you're generating. So hot air is obviously less dense and cooler air. So essentially you're actually having the opposite effect. So when we start getting to the higher loads and we're driving a car on track under full throttle conditions, we're obviously seeing a huge amount of intake heat. So is what we find when we start driving these superchargers to real higher RPMs, we actually end up losing power in the long run, because as the intake temperatures come up, essentially the ECU will apply correction, so it will reduce a whole host of manufacturers to do, a whole host of different points to do that. So reduce timing or fueling or whatever. It might add fueling, which will reduce power. So that's why we tend to stay away from the higher drive ratio. We have tested some of the V8s to destruction with that. So we recommend on the 4-litre to stick with the lower crank pulley. If you are going to add a top pulley as well, you do need to add intercooling to it. So the V8s run a water-cooled intercooler setup. So they have a charge cooler, which is either side. That's where the supercharged logo is, and that's essentially a radiator or a charge cooler. So the air is forced through that. And the water that is running through that is cooled by a front-mounted radiator as well in front of your normal radiator. So if you are going to run excessive drive ratios and run the superchargers to the top limit of that, we recommend to upgrading that. Now, moving over to the 4.2, the 4.2 already has a larger crank pulley fitted from factory. So that's one of Jaguar's modifications that they did to see the 426 bhp rather than the 370. They also obviously changed the engine very slightly. Some of the models had VVT, some don't, which does also give a small increase on power. But from interestingly, with a lot of our testing, it's a story for another day. But VVT advanced on some of these was actually more emissions based rather than performance. So with the 4.2s, we recommend that you modify the upper pulley. We go with the 6% on those. That is the best balance in our professional opinion, and it's something that we've tested on track like time and time again. Now, when we have run the 10% pulleys on the 4.2, we have seen on the dyno initially more power on the first dyno run, but when we've started pushing the limitations, we've actually lost more power than we've gained because of, as I explained earlier, the difference in the intake temperatures, reducing efficiency, etc. So we find that the best balance all round is a 6%. As some of you probably know, we have a couple of the ex-Palmer XKRs that we spend a huge amount of time on track. All of those have got 6% pulley. They're really sensible to fit, and with the later 4.2, with the later management systems, we can also offer some good tunes to go with that. Last but not least, we'll talk about the 5-litre application. So this is with the TVS 1900 Supercharger. So this is Eaton, I believe it's their latest generation of charger. I'm not aware of any other modifications they've carried out. So this is far more efficient than the earlier Superchargers. So this is why, going back to the fact that manufacturers are trying to use this engine for a long period of time, this is why Jaguar, the 5-litre Superchargers, comes in a huge array of power outputs. So I believe figure-wise, the TVS style charger is about 12% more efficient straight off the bat than the earlier chargers. So you can push the limitations of these chargers a lot. So we offer an upper pulley for these. We do a crank pulley for the 5-litre Supercharge, which I'll come to in a minute. Now, the upper pulley, again, that's around a 6% increase. One of the things we do with the 5-litre, which is, I believe, we're the only other company that offer this, is most of the Supercharger pulleys, unless it's a race application, are heat shrunk to the charger nose cone. So essentially they're heated up and then shrunk to the charger nose cone. So getting them off can be quite difficult. I don't know if any of you seen the episode on when we did it on Dale's car, when I kind of said it would take 10 minutes and it ended up being kind of a 2-hour battle trying to remove the pulley because it was so seized on there. So they can be really awkward. So we've got a couple of specialist tools to help with that. But ultimately we have to do the same to fit the pulley back on. They're shrunk back on, they're made from stainless. Whereas on the 5-litre application, I don't know if you can see on the screen here, we actually offer a boltable pulley. So that means essentially you can take it off and remove it if you need to, refit it at any time. So when we were developing these, we were able to run different supercharger ratios by simply just unbolting it and changing the pulley ratio to see whether we could gain or lose power and what that did. So it's a taper lock design. It's simply we pull the other one off. And as Dan knows, he's fitted a huge amount of these. It takes so much less time to fit these, and the consistency of fitting these is so much easier. So we're that confident we're happy to just send these out in the post to customers to just fit on their drive. They're that straightforward. We also offer the tool that you can remove these with as well, if that's any help. So that saves a massive amount of time. Unfortunately, the pulley does cost a little bit more because we have to make it in 2 parts essentially. So going back to suspected performance gain. So some of you probably have seen some of the crazy figures that are achievable with the 5-litre Supercharge. The earlier car started with 510 horsepower. That is on a Denso management system. Going back to what we were saying earlier, that is a little bit more awkward to tune, and it is a slightly more limited on what we are able to offer on that. The 5-litre generation Denso, we can offer far more than the earlier car. Now, when we go over to the Bosch management systems on the 5-litre, that's when we can really start pushing the boundaries of these cars. So with the earlier 2010 kind of derivative up to about 2012, we see around sort of 50 to 60 horsepower, which is a really big improvement on those. And we obviously tune the vehicle to match the pulley we fitted. That's kind of what we expect to see, and it's something that we've seen consistently with these. It's the same with the 4.2. With a 4.2 Denso, we see realistically around the 40 horsepower gain. It is a little bit less with that earlier car. Now, when we go over to the Bosch management systems on the F-types, XKs, all of those different generations in the XJs, we can actually see around 100 horsepower gain with the pulley and the tune to match. As I was saying, the difference between the factory option is in the tuning already. So one of the things that we have found on those models is, as they are drive-by-wire throttle, they're non-cable related, so they have a sensor on the throttle and a sensor on the throttle body. They actually reduce full throttle position. So there is multiple reasons why they'll do that. Sometimes you can actually gain power by reducing the butterfly at full position. But one of the things they do on the XK is they don't, or sorry, the F-type, is they don't allow you to actually have full throttle when you're demanding it. So when they go over to the SVR, that's why they can offer you a 550, or an RS, they can give you an extra 50 horsepower on the factory, because they're just tweaking that software. Whereas when we add a pulley to that, we're adding more boost to the mix. We can then modify again and go on. Now, we've actually tuned the 5-litre supercharge. I think the best one we've seen, Dan, is around the 630 mark, isn't it? Which, I mean, it is a huge amount of power. It is almost nearly unusable on the road, to be brutally honest.
It's frighteningly quick.
Yeah, exactly. And it is quite a lively car to drive. So ultimately, the best all-rounded package that we offer, and most of the other companies also do it, is your stage one, which is your pulley and tune. Anything after that, we have to add quite a lot of other modifications. So going over to the lower supercharger pulleys, we can do that on the 5-litre supercharge. But same as I was explaining earlier, you are then starting to push the TVS 1900 to its maximum RPM. You're getting to where it is inefficient, so it's not in its sweet spot, as we kind of say, and it's generating a lot more intake heat than it would do at the lower pulley ratios. So then again, you have to go down the route of looking at adding in different intercooling to cool that. We can do that by adding aluminium radiators at the front. As I said, they are also water cooled as well. So they've got an intercooler internally to the V. That's your charge cooler. And then you've got an external radiator at the front of the car. So we can increase the size of that. We also sometimes have to increase pump size to move the water around quicker to cool that. And then we can run these larger drive ratios. But in our honest opinion, going away from that, the stage one ultimately is your best value for money and your biggest step. When you start increasing the drive ratios to that kind of level, you're unfortunately having to spend quite a large amount of money to do that, and it ends up being a lot smaller gains, if that makes sense. So with a stage one, like I said, on the 5-litre, you can see 50 to 60 horsepower, sometimes up to 100 on some of the Bosch management systems. And then to gain that extra 30 horsepower, you're having to modify the exhaust, modify the caps, modify all the intercooling system. And then potentially when you're getting out track at these really high loads, then you might actually see slightly less power because you're running a lot of intake temperatures. So hopefully that kind of covers all the different models there. I mean, I can delve into a lot of other details on different vehicles, but that's very generalized across the V8 applications that are used in the modern Jaguars. So I'm not going to go into too much detail on this, but supporting upgrades. Sometimes, as I was saying earlier, when we're tuning these, there is other modifications that are sometimes more beneficial to get the best out of a car rather than that all-out power. So, as I said earlier, one of the companies we work with is Tarox. We might even see if we can get them on a seminar to talk about some of their products, but we've developed a huge range of those, so we often recommend brake upgrades. Sometimes chassis upgrades and suspension upgrades can give you more if you're using it on track, or even for fast road use, than that extra 20 horsepower. Going back to the air filters, we've developed the range with Pipercross. Same again, if you're matching that with a tune, you can see quite good gains in doing that. And there's just an example of some sports cats there. So yeah, thanks for listening, everyone. Hopefully I haven't delved into too much detail. And as Andy was saying earlier, if there is any specific questions, let me know. And if there is any other bits people want some more information on, I'm sure Andy might at some point wouldn't mind maybe arranging some talks on some specific models, and we can talk about the modifications just for those models only. This is very generalized tonight.
Thank you ever so much, Tom. That was absolutely fantastic. Very informative. There have been quite a few questions as we're going through, Tom. So in the interest of time, I'm just going to fire some at yourself and Dan, if that's okay.
Yeah.
So John H has asked, what sort of transmission loss would you expect from a GM 4L80E on my XJR6?
That's really interesting, actually, because we very rarely dyno the early XJR6. Most of what we do is with the manual applications. But to give you an example, obviously, as I said earlier, we nearly see 50 horsepower potential losses on the ZF gearbox. So you do see quite a lot of power losses through a torque converter, essentially. So it might not be as extreme as that, but you unfortunately are going to see a fair amount of difference there. In your losses through that transmission, I'm afraid.
Cheers, Tom. Somebody, there's no name attached to it, has asked, and I think this refers to one of your previous slides, Tom.
Yeah.
Refers to what was the torque spike at 2,500 revs on the dyno run.
Okay, that's really interesting. I'll go back over to that. That often is wheel slip. And that was one of the things I was going to talk about. So that is essentially probably where we've had wheel spin. You can see it's affected on the BHP spike there. I think you'd probably agree with that, Dan. That's more than likely what that is.
It's where the wheels are spun and then they've gripped and accelerated the roller a lot quicker than the rest of the run. So it's seen more torque generated at that. And
at that point,
the BHP hasn't jumped as much is because BHP is a calculation of torque by the RPM. So that's why it's such a little amount there. But
yeah, it's something that we do sometimes struggle with. Going back to what we were talking about earlier with a chassis dyno against an engine dyno. Engine dyno is bolted essentially to the crank. We're measuring at the wheel. So we've got all of these different points that can cause us issues. And when we're running kind of quite large power through these cars, the only thing that is gripping it to the roller is that tire. So different tire brands can give us different issues on a dyno, but that's probably what that is, I would say, is wheel spin.
Thanks, Tom. We've got another slightly interesting question here. In the event of an accident, would an insurer be able to identify if a vehicle has been remapped?
So this is an interesting one, because this again, I'm glad you brought that question up. Technically, I don't know how far an insurance company would go into it. Now, with some of the modern ECUs, for example, on the latest generation F-Type, when we have tuned those, they actually log a fault code. And the fault code they log is for warranty purposes. And they actually log that there's a non-factory file uploaded to that ECU. Now we've been tuning these for a couple of years. We've actually found a way around that. Now, ultimately, say, for example, if we look at the earlier F-Type, if we were to tune that from factory and there was no physical hardware installed to the car, so there was nothing that an insurance underwriter could say, that's not standard, then ultimately it is extremely difficult for them to tell. They wouldn't actually be able to take a read from the ECU. And I don't know if you agree with that, I don't think it's worth their time to do that. They would physically have to take another read from a car with a similar VIN range, similar specification, and essentially almost overlay that to be able to see the differences. We've got to remember we're only modifying small parameters within that ECU. So ultimately, I think it is very hard for them to tell whether it is, unless there is a permanent file logged, or I guess if there was a major fatality or something like that, and they were saying it was down to a dangerous car, then I guess they could look into it as far as they wanted to. I mean, they could go to an independent, and I guess, Dan, I don't know if you agree, they could try and compare something similar, but it is a major undertaking to do that.
I mean, coming on to that, a lot of the dealer software can't even see that the vehicles have been modified. Hence why they're going into logging fault codes, because it's easier for them to see.
Yeah, that's a really good point, because Dan spent a fair time at BMW as a master technician there, didn't you, with the M models, and on their diagnostics, because as we were saying earlier, the BMW, the VW market is far more there's a lot more people that are tuning in that. They've actually now got to a point, if I'm right, Dan, was when you take a read or you're doing a software update, without Dan knowing, that file's automatically being sent to Germany if it's under warranty. And if they see anything that isn't factory, they'll void the warranty on that car instantly. So yes, it is getting harder for us to do these kind of things, but we're obviously trying to do cars as soon as they're new so that we can get around these problems. And with that later F-Type, we have managed to do it the same as the earlier cars where there is no fault code log. But with the Jaguar diagnostics, at the moment, they aren't doing anything like that. Hopefully that kind of covers that subject, really.
Thanks, Tom. Thanks, Dan. Next question is from Mike Corthra, who says, having owned a highly tuned supercharged rally car, the uprate in mid-range torque would reveal the weakness in the chain, which was not the engine, but the gearbox. Any limitations with Jag boxes?
So yes, there is. So one of the things I didn't actually mention, which I'm glad you picked up on, is most of the Jag applications use a ZF gearbox. We know where the limitations on torque are on that, and there is actual calculations within the ECU to reduce that to avoid damage. Now, with some of the XKRS models, because the manufacturers have to leave a far bigger safety margin when they're developing these cars, because they're like designing them to last 7-10 years, 100,000 miles. The RS and some of the other applications have a different torque converter in the 6-speed and 8-speed gearbox options, I believe. So with those applications, we have got a larger safety margin, but we don't push these to the limitations where we are going to cause gearbox or diff damage. In a race application, as we found out on multiple occasions, haven't we, Dan, with the torque that we're running on the XJR6 with the Catrag 290 gearbox, we have found both limitations of gearbox on standard, and we have found limitations on differentials as well. Now, what's interesting actually with that, just going back to the motorsport, is actually how far over those limitations we were before we actually started seeing issues. And it's the same with the ZF gearboxes. They say a limit and we stick within them, but ultimately there is still quite a lot of safety margin in that.
Thanks, Tom.
Touching back into the ZF8, it's actually now point where they're stronger than the manual boxes that they could produce. I know certainly in the BMW circles, the F90 M5 runs a ZF8, which is essentially the same gearbox within the running in the new Gen F types and the like. And there's people with over 1,000 horsepower and matching torque in those now. So we're certainly well within the limits there for the gearbox, as long as it's well serviced. That's the main thing, is keeping on top of the servicing on those ZF8s. Yeah,
that is another point. We do also, if we are doing any tuning options, we'll always do kind of a health check and make sure some of these points have been covered. So gearbox serving and stuff, it's another topic on the Jaguar range, but Jaguar status sealed for life. We always recommend to change the oil, and so does ZF. So.
Chaps, we've just got a few more minutes left, but we've got 3 questions to get through. There have been some questions on the chat that have been answered by other people on the chat, which is very useful. Mark Nichols says he's got a 2010 XKR. Would this be a Bosch management system?
Say that again, sorry.
Mark has said he's got a 2010 model year XKR. Would this be a Bosch management system?
No, so the 2010 is on the earlier Denso type management system. I believe it was 2012 at a chassis range where they changed it to the Bosch side.
Brilliant, thanks, Tom. Wayne has said he's got a 2005 XJR 4.2, which currently is at 400 horsepower. What would you get it to with ECU tuning and a change in pulley?
So if we go with the 6% option, on average, we regularly see around a 40 horsepower increase on those. That's with a tune and the top pulley fitted. We also, as I was saying earlier, combine that with the air filter at the same time. It's just part of the package. The later car, we can see a little bit more of an increase just due to the age of the management system ultimately. But as I was showing on that dyno graph earlier, one of the talking about overall figures is one thing, but you do gain a massive amount of mid-range torque with the supercharging pulley and tuning it. So although you might not see as such a large overall brake horsepower figure, you will gain quite a substantial amount of torque, and often that's where you notice it.
And just moving on to the last question, there has been a cheeky question, which I'll get to in a second, from somebody called Dale. But
Don't know, Dale.
Before we get to that cheeky question, Richard has asked, is it viable to fit a manual gearbox to an XKR, an X100, to obtain a power boost and increase drivability?
So, yeah, ultimately, we do manual conversions for the 100. It's something we do a lot. As I was saying, drivability-wise, you gain a lot more control over the car from a driver's perspective. And as I was saying, you are going to see more wheel power overall. So yes, it's a great thing to do. We did it to Dale's car as a drivability thing. That's actually running standalone management. It's not just, unfortunately, a straightforward job of just bolting a manual gearbox in, as you probably know. Obviously, all the Jaguar range of that year was designed to be an automatic. So you either have to trick the car into thinking it's still an automatic, or you have to integrate some kind of software or standalone management ECU to control it as a manual car. So in principle, yes, it'd be massively beneficial, but to actually do it is quite difficult to do, I'm afraid.
Thanks, Tom. I hope that's okay, Richard. He's giving you the thumbs up there, Tom. I will ask Dale if he can put himself on video and take himself off mute. He can ask that question himself to you, Tom. Hello, Mr. Dale Masterman from Maguire's. Hello.
I just thought I'd just gate crash the whole chat and just make it about me.
You're missing out, weren't you? I did include a photo of your car. Hopefully you see.
I saw the engine bay, yeah. Now, I just wanted to know if I can come and drive the car soon. No one else has.
Yeah, so those of you who've been following the series, obviously this is Dale's car, but Dale's never seen it or driven it.
Cars are only built for the internet.
So
it looks great, Dale. It really does.
Oh,
mate.
good. I'm glad.
I think more people have seen it now as well. So, and I think I'm the only one that's actually. I think Dan might have driven it actually as well, so he can tell you.
Even your dad's
what it's
driven
like.
Could I just say, Tom? Obviously, a huge thank you. But for anybody who wants to ask more questions, what's the internet address and telephone number, Tom?
So we've, like I said, the email address, it should be in the magazine if there is any technical separate to performance. So the email address is inquiries@swallows-jag.co.uk, or any of the performance inquiries send to inquiries@swallowsracing.co.uk. The landline here is 01934 750 319, but to be honest with you, the best way to contact us is via email. So I'm often in and out the office, so send us an email. I can send you over any info. And like I said earlier, if there's anything that anyone wants to go into any more detail later down the line, I'm sure, Andy, we can sort something out, can't we, if there's any model specific stuff. But we have got some other chats lined up, haven't we?
We have. We are going to be looking at the brakes, the suspension, and the exhaust upgrades that you do as well, Tom, that you've mentioned. So we're going to have other seminars like this, and please look out for them on the Friday Spotlight and on our website as well, because there'll be opportunities to register for them on there. So just keep an eye out over the next few weeks. There's also one coming up with SNG Barrett, which I think will involve cooling fans on an E-Type. And there will be another technical seminar with Ken Jenkins and Andy Waters, probably in May, I would imagine. So we are doing regular online seminars now. Keep an eye on the website and the Friday Spotlight to register for these. All of these as well are being recorded, and they are going on the YouTube channel as well, which we are growing now. So if you did want to refer back to this in any way, then obviously have a little look at the YouTube channel and the Swallows website, because the Swallows website gives details basically everything that you've talked about tonight, Tom, doesn't it?
Yeah, it should do. If, like I said, if there is any questions, don't feel afraid to just send us over an email. I know we've covered quite a lot, and it's not necessarily model specific. It's been a bit generalised to start off with.
I know that we've got our chairman Ray on the call, and as I always do, I always go to Ray at the end of a call just in case he's got a few words to say. I think I may be right in saying that Mr. Searles has actually bought something quite special recently.
I can neither confirm nor deny.
No comment.
But I may have had an ulterior motive for being on the call.
So how much do you say you could get an XKR up to? 630, did you say, Tom?
Yeah, it's doable.
Oh, I think we can try that,
And
can't we?
I think I said that certain models have a stronger gearbox as well, Ray.
I think you also said it was undrivable on the road.
Oh, I forget that bit.
Well, we'll see. We'll find out tomorrow, won't we, Tom?
Yeah, absolutely.
Yeah. I hope Gary's enjoying Darlington.
Yeah. I haven't heard anything, which is good news.
That would be good news. Anyway, stop boring everybody. Thank you very much, Tom.
No problem.
Thank you, Andy, and great talk this evening. Lots of good information. I'm looking forward to the rest of the series. So keep up the good work. Thank you for that. And Andy, we look forward to the next one. Thank you very much, everyone.